Start. So, welcome students of the introduction to IoT course to the first live session of this semester. So, I am very glad to be able to have a live discussion with you. Already some of you have sent your questions that you want to ask me. So, I would try to answer them to the best of my knowledge. And I hope that all of you are having a fun going through the different contents of this course. So, it is a course that is of tremendous importance. So, since its inception a few years back, this was the first course on IoT that was proposed and in our country, and since then lot of universities and colleges, they have tried to adopt the course structure, the course materials from this particular course for coming up with their own individual semester long courses on IoT. I am also serving in the different committees of course curriculum in the different universities and different other institutions of our country. So, in a sense that this particular course has got a lot of impact, like for instance, apart from all of these, I from the very beginning, roughly every semester, every offering, more than 40,000 registrations are coming every semester. So, 40,000 roughly every run of the course. So, this course is a very popular one, and I am very glad that the time that we spent to record this course that is being that has been fruitful, and every semester, every time that we offer, we get lot of emails praising about the contents of the course and how this course is benefiting everyone. So, in a sense, we are very glad that this course has been impactful to the different audience different audience of our country, not just the students, but also different faculty of the different colleges. We have students coming from large number of different industry. So, we have students coming from universities, colleges, institutions, government, different. So, our students are basically different government officials, different industry persons, and not only that, students are also coming from different parts of the world. So, we have students coming from US who are participating in the course. We have students from different parts of Europe, different countries of Europe, Africa, and almost every nation. So, this is a highly popular course, this one and the other associated course which is also running this semester, Industry 4.0 and Industrial IoT, that is also a very popular course. So, now let me start trying to let me start answering your questions that you have sent offline. The first one is the applications of IoT. So, this is a this is a technology. IoT is a technology, rather it's an amalgamation of different technology. It's not just one technology. It's a it's a different technologies that are put together in order to solve certain problems of certain types, right. So, there are lot of applications of IoT, lot of applications, and IoT is becoming more and more popular every year. Every year government, academia and private sector, everywhere you go, everybody is talking about IoT, everywhere, every application domain, be it agriculture, mining, space, civil engineering, road infrastructure, everywhere people are stepping into this particular domain of IoT. So, IoT has got a big impact, lot of footprint is available, is visible. So, specific applications, direct applications would be the building of smart cities and smart homes, that is what I have talked about in the course as well. So, we if you go through some of the case studies, you would be able to see some of the ideas on how smart cities can be built, how smart homes can be built. So, homes for instance can be made smarter, right. So, how they can be made smarter? Through the adoption of these IoT technology, different sensing, actuation devices, all of them network together, home room to room connections, connectivity between the different rooms, connectivity of different home appliances such as microwave ovens, the stoves, stoves for cooking, the air conditioners, and almost everything, so all of these things they can all be connected together to serve different use cases. As I have said number of times in the course itself, if you go to the lectures, so applications of IoT is something that I have elaborated in the different lectures in the course. So, one thing that I would like to tell you is there are a lot of problems that are there, a lot of real life problems in the society, not only in the homes but also in the society, in the industries as well. So, IoT basically is a technology that can help address many of these different problems. So, problems which can basically help automation, right. So, full-fledged automation, reduced or almost reduced, negligible or almost no human intervention, those are all that can be done with the help of IoT based technologies. So, machine to machine connections, smart factories, smart homes, smart cities basically different sectors of the cities, different sectors such as the transportation sector, the education sector, then the judiciary, and many others, right. So, all of these different sectors in a city can be interconnected with the help of sensors, actuators, etc., in order to make them smarter. So, smart homes, smart cities, smart industry, smart factory, these are all different applications of IoT, and more is coming. So, as you can see, day by day the adoption of IoT is increasing manifold. So, lot of work is going on, lot of funding is being poured, not only in our country, throughout the globe, everywhere. Everybody is talking about IoT nowadays. IoT is just a booming technology. So, everybody is talking about IoT and everybody wants to be there. They are trying to learn different concepts through different courses, books, different information that are available publicly online and offline. So, everything is happening. So, everybody is gearing themselves up towards IoT adoption to help them solve their practical problems that they encounter in their day to day life. So, both in the industry front as well as in the home, in the other societal fronts as well, and agriculture. We do a lot of work on agriculture, IoT in agriculture, IoT in mining, these are all some things that we do, IoT in healthcare, IoT in underwater domain. We do a lot of work on underwater Internet of Things, underwater surveillance, right. So, but the thing is that we do not have complete systems in place yet, right. So, these are very challenging. So, IoT is not about purchasing some Arduino and Raspberries and putting them together and communicating between them. So, there are lots of problems, lots of challenges when you try to internetwork these different things, these different challenges, these different objects, you land up in different challenges, and that is what makes IoT interesting, and why there is so much of funding that is being poured on to develop IoT. So, there is lot of benefit that is there in terms of IoT adoption. So, IoT adoption comes with lot of challenges, but there are lots of benefits once you are able to overcome those different challenges. So, that is about IoT. So somebody, the next question that is asked is, what is IoT? That is something that I am sure that number of times you have heard me through these lectures, if you have listened to the lectures. So, what is IoT? Internet of Things. Internet of Things means Internet of Objects, Internet of physical objects like the TV screen that you are seeing in front of you, the computer screen that you are seeing, to the camera, the lighting system, so anything and everything, any object that you can think of, they are all different things that can be interconnected together to help address different questions or different challenges that one faces in the day to day life. So, that is IoT. So, the next third question is, IoT and machine learning. I think the question is, what is the relation between IoT and machine learning? There is a lot of relation between these two technologies. Both of these technologies have been independently evolving over the last few years. IoT has been evolving for its own reasons, and machine learning has been also evolving. So, the question is that how machine learning can help in the evolution of IoT and vice versa. Machine learning is something that has been there since several decades, and only in the last few years machine learning has become very popular due to its different capabilities of addressing issues such as predicting certain things, doing finding out clusters, getting more insights about processes, getting insights on the data that are coming through. So, machine learning is helpful in these kind of problems. So, how IoT and machine learning fit together? They fit together because IoT is data centric. Basically IoT systems throw lot of data out from these systems, and what you are going to do with those data? You have to get insights. You have to get insights about what is going on, and for that machine learning can help you in order to get insights about operational activities that are going on at present, to predict what might be happening in the future, predictive issues, predictions, and also prescriptions. So, based on the data that you have, prescribing about what might be what action should be taken to the corresponding stakeholders. So, machine learning comes hand in hand. It is a powerful tool to evolve IoT, and IoT also has a lot of role to play in the evolution of machine learning in the current context, because you see most of the machine learning adoptions in the industry are where IoT systems are required, and similarly in the regular society also there are a lot of adoption of machine learning to solve different IoT adopted systems. But the challenge is that regular machine learning solutions are not cannot be directly applied in IoT, because IoT systems are highly resource constrained, as you have heard me through these different lectures. So, resource constraints in terms of communication, computation, buffering, and that means memory, etc. So, everything is highly constrained, right. So, machine learning basically applying the traditional machine learning concepts cannot be done directly in those resource constrained environments, because the traditional concepts were proposed for non-constrained systems like the regular internet, regular high processor systems. So, those have been there. So, nowadays people are talking about resource constrained machine learning. So, one of my PhD students, she is working on resource constrained machine learning, right. So, resource constrained machine learning means what? That whatever you have been doing in the machine learning domain, traditionally you want to do it in IoT systems, right. So, resource constrained machine learning is a field that is evolving, and a lot of potential in terms of research exists in this particular domain. And another thing that I would like to mention is that there is most of the work. So, most of the lectures that you will hear not only over here, but also globally, these are all futuristic, right. So, we would like to be there. This is the vision, this is where we stand, and the rest is basically based on the foundational concepts that we have, how we can evolve ourselves, how we can make ourselves better. So, that is what you will find. So, most of it is futuristic. So, through the adoption of IoT, basically you are trying to make smarter systems, smarter environments, and so on. So, everything you want to make smarter, right. So, you want to make everything smarter. Smarter means what? Reduced or almost no human intervention, everything happens in a predictive way, in a better way, with lot of efficiency, standalone on its own, no human intervention. So, like that, so better improved efficiency of the systems, improved functioning. So, all of these things are possible. So, next question is, when will IoT come to application really? Well, IoT applications are already there, right. So, it is not like IoT is something that IoT is a technology. The good part of IoT is that IoT adoption is happening very fast, very fast. In small scales, IoT adoptions are there everywhere, it is there, right. So, right from the academic environments to the industries, I have seen industries in different patches IoT implementation, sensors are being deployed to do something locally. Now, you want to scale it up, everybody is trying to scale it up, right. IoT, if you want to just have localized things, then the full benefits of IoT cannot be achieved. So, what you want to do is you want to interconnect these different local systems, IoT deployments, everything put together, you want to interconnect them, the data, the machines talking to each other, the different things talking to each other, the data coming somewhere in a distributed or in a centralized manner, then you process all of them, you get more insights, deeper insights, better predictions and improved efficiency. This is what IoT is all about, right. So, IoT is already there. In reality, it is not totally futuristic. There are futuristic visions. IoT is scaling up. Upscaling of IoT deployments is a huge challenging task. It is happening in phases everywhere. I visit different industries. Very recently also I visited an industry and there also we have seen that in different patches IoT adoption is already there, right. So, but still things do not stop over there. So, everybody in the different industries, the people like us consulting for the different industries and so on. So, what we are trying to do is to do better and better and better. So, through the adoption, more and more adoption to upscaling of these different systems and so on. So, the next question is how to develop the sensors. Remember that sensor development is a completely different ball game, right. So, we do not, as you have noticed in this course, we do not talk about sensor development, although we introduce to you the sensors, the characterization of the sensors, the different types of sensors, the different types of errors that one could get with different types of sensors and so on, just to give you a theoretical treatise. But the thing is that sensor development is something that is very specialized and only very few people do. So, if we are talking about MEMS based sensors, people working on microelectronics, they many of them they work on just sensor development. One temperature sensor, the characterization of that particular sensor, the material that is required and how that material is going to behave in terms of when it is exposed to different external stimuli, right. So, how it is going to do, what will be the electrical characterization in terms of the output, the current output current or output voltage, right. So, basically what happens is you have a material, you try to put some, you subject that material to the stimulus that it is going to have, and then depending on the type of sensor, if it is an electrical sensor, then there will be some change in the current characteristics, or there will be some change in the resistance characteristics, or there will be some change in the voltage characteristics. So, it is that particular characteristic that will have to be captured, and you will have to draw meaning out of those different change in the characteristics. So, sensor development is something that is highly focused, highly only a smaller community they focus on the sensor development, and it has been there, so last several decades. There are groups who work on sensor development, sensor characterization, they work on this particular thing. So, for instance, I work along with my colleague from material science department of IIT Kharagpur on so we do air pollution monitoring, right. So, basically the particular group from material science, what they do is they test different materials and look at their electrical characteristics, change in the electrical characteristics when that particular material is subjected to different pollutants, different harmful gases, for instance, right. So, this is like a multi-year kind of so every gas, every material they work with, it is a highly challenging domain. So, they work on those things, and their research papers are basically on the characterization of those materials that they use, and what is the change in the resistive characteristics, resistive properties, capacitive properties and different other electrical properties. So, current voltage change, etc. So, they try to calibrate those things and try to get understanding about how those materials are going to behave when they are subjected to these different harmful gases or different other external stimuli in general. The last question that I see over here is internship opportunity. So, internship opportunity, you please contact NPTEL. We take a lot of interns, in the summer as well as in the winter. Winter we take only very few, but in the summer at least 2 months of internship we can provide to the top quality students of this course. So, you please contact NPTEL directly, do not send a CV to me. You contact NPTEL directly, and it is high time that you contact them, because we are soon closing our internship portal to join our group, the SWAN group, and if you are interested, contact NPTEL immediately, and they would be able to guide you about how what is the process to shortlist you, and in case you would be taken to work in our group and any other professor that you would like to work with. So, contact NPTEL directly, and for our group, in case you are interested, please contact NPTEL immediately, because in another 2 or 3 days we will be closing our opportunity for working in our group. Next question that I see is IoT protocol stack. So, I hope that you are going through, before asking these questions, I hope that you are going through the materials that are given to you. So, if you have gone through the materials, you would be able to, you must already be knowing that there is no standardized protocol stack like OSI or TCP/IP. For IoT, we do not have a standardized protocol stack. We have different proposals that are there, and many of which I have already covered in the course. I hope before asking a question, you go through the materials first, and then in case you are not able to understand anything that I have covered, you ask me at that point, right. Do not ask me a question to explain a concept that is already explained over there very well several times. So, IoT protocol stack, as I said before, it is not standardized. There is no one stack like OSI 7 layers, TCP/IP 5 layers, there is nothing like that. So, the thing is that there are different proposals, some of which I have already covered in the course. So, we have layers such as the sensing layer, then you have the network layer, like different types of networks like mobile networks, wireless local area networks, sensor networks, and so on. Network layer is there. It is not the same network layer like the layer 3 of OSI. It is not the same. The name is the same, but it is the purpose, the functionality is different. So, that is layer 2. Then you have other layers such as the interface, the application layer. Then there is a service layer that is in between. So, a service layer is very important in IoT, because IoT is all about services. Service centricity is very important in IoT. So, service layer is there. So, service composition, decomposition, integration. So, whatever you want to do with these services, service offerings through the application layer, this is a very important thing. Plus, cloud based IoT solutions are also there, where you integrate IoT with cloud. So, all these different models of cloud, such as software as a service, platform as a service, infrastructure as a service, all of these can be integrated with the existing the existing IoT systems. So, basically a lot of proposals are there. You please go through, everything has been discussed in the course number of times, and there is no I do not think that if anybody has heard the lectures, they should be asking this question. So, anyway, I hope that I have been able to answer still the question, but I would urge you to go through the material once again. Second question is difference between wireless sensor network and IoT. Wireless sensor network is networking of different sensor nodes. IoT is more than that. IoT systems are not merely networking of just sensor nodes. IoT systems are beyond that. In IoT, you have not only sensors, but also actuators, cloud, inferences, analytics, everything put together, everything packaged together. There is overlap. There is a big overlap between wireless sensor networks and IoT, but these are not interchangeable technologies, right. So, in order to build an IoT based system, essentially what you are doing is you are interconnecting these different IoT wireless sensor nodes. So, in a sense that you are forming a wireless sensor networks, but it is much more, it is much beyond just wireless sensor networks. Practicals for IoT, how to do our own. So you know, there are few lectures on how you can build IoT based systems. We have introduced to you Python, Arduino, Raspberry. You know, please go through the lectures. There are lectures on these that will be there in a you know, if you have not already gone through, in a few few more days you will be getting those different lectures for you to go through. So these are all there, right. So basically you need to you know, if you want to build your own IoT based system, so the simple thing that you can do is to turn on the sensors in your mobile phone, right. So turn on the sensors on your mobile phone. Those sensors, the accelerometer sensor, the gyroscope sensor, etc., that you have on your mobile phone, those will be collecting the data, sending, maybe you know, you connect your mobile phone to the cloud, sending the data to the cloud, run some simple analytics on the cloud, and based on the analytics feed that signal back, the analytics back to the mobile phone. So you have a closed loop, a closed circuit. So mobile phone to cloud, analytics over there on the cloud, storage of data over there, and the result back to the mobile phone you know, for display and taking further action. The very simple implementation that you can do. Similarly, you could use standalone external sensors such as the temperature sensor, humidity sensor, lighting sensor, you know, many other sensors that are available. Many of these are all available commercially. So you can even order many of them online. So you can procure those sensors, you connect those sensors to maybe your Arduino or any other like Node MCU, etc. So you connect all of them, collect the data, do some processing over there, send it to a Raspberry Pi maybe, and from there to the cloud, on the cloud you do some analytics and send the data back to your you know, whatever device, maybe the mobile phone, and from the mobile phone you try to actuate something, right. So these are like very simple, naive yet important learning you know, exercises that you can do in terms of implementation of IoT. So for this you need what? You need small sensors, you need actuators, you need Arduinos, you need Raspberry, you need to learn Python, C programming, small little bit of Java, etc. You need to learn all of these, and many of these are already covered in this course. So if you have gone through the course, you know, we have already given you exposure to many of these things which will help you to dig further. This course will never make you, you know, an expert in the domain of IoT, but this course can give you enough knowledge to build your own IoT systems deep enough to get your actual problems resolved. Exam pattern, all I can tell you, I will not be able to give you more hint than saying that exam pattern will be mostly MCQ, multiple choice question. So so rest of it, you know, I cannot divulge. Sensors versus detectors. So basically both are the same. Detectors are used for physical sciences, for responding to energy signals and forces, and sensors are more or less what I have you know, talked so many times so far. Next question is, what is RFID, radio frequency identification? There in RFIDs, basically what you have is a RFID reader and a RFID tag. The tag basically will be magnetically coupling with the reader, and from the tag to the reader the data are going to be sent, and same thing vice versa can happen. So basically through the magnetic coupling, the data can be transferred between the tag and the device. So go through the lecture on RFID. So we already have this RFID technology explained in one of the lectures, so please go through it. As M2M is a specific IoT solution provided by service providers, is IoT a specific area in AI? This is too complex, convoluted, unnecessary question. The reason is that these are all different, you know, this M2M is a technology, as I have said in the course itself, machine to machine communication, right. Machine to machine communication is required for IoT implementation, many of the IoT implementations. Same thing for artificial intelligence as well, machine learning as well. So, all of these things are enablers of IoT. So, these are terms that you will be encountering in these domains, right. So, all of these they have overlapping scope, they can be used working with each other in order to cater to the development of IoT based systems. Future of IoT, great, all I could say. IoT is evolving every year, every day it is evolving. So, even like what we have seen last few years, right now IoT adoptions are even more. So, we have IoT implementations, we can see IoT implementations. I myself have been working with IoT for over a decade, and I have seen like IoT implementations are happening everywhere. Every time I can see that IoT implementations are happening. So there are so many projects that are running in the academia, in the funded by the government, industry based IoT projects. Industry 4.0 is a concept which is heavily dependent on industrial adoption of IoT. So, and industry 4.0 is a booming paradigm in knowledge area in the context of industries, manufacturing industries particularly. So, factory 4.0 for instance is something that is very important in the industries at present, particularly the manufacturing industries. So, future of IoT is great. Smart homes, smart cities, smart industries, smart factories, these are all things that are coming, and coming for good reasons, not just for the sake of it. It is all coming because these are technologies that are going to transform the existing processes, existing businesses, existing societal existing societies. So, everything is being transformed with the help of these technologies for good reasons. Can sensors and actuators be connected to Arduino boards wirelessly? You can connect. The answer is that you can connect. So, some sensors and LEDs can be directly connected to the ZigBee, and then you can connect from one ZigBee module to another ZigBee module, you can connect. So, like that you can form a network. Next question. Humidity sensors in home automation. I do not know what you would like to ask through this question. If your question is that can we use humidity sensors in home automation, of course you can. So, humidity is very important, monitoring humidity is very important in homes. Humidity is an important environmental parameter that has to be monitored. So, based on humidity, if the room is too dry, if the room is too wet, etc., lot of people suffering from asthma for instance, right. So, they are basically vulnerable to change in humidity, breathing problems, asthma problems and many others, right. Skin problems, dermatological problems, these are all based on many of them are based on monitoring of humidity. So, humidity control in the rooms is very important to many patients and many individuals. So, these are very important in home automation. In wireless sensor network, which communication standard is most common? I think I have answered this already. So, there is no communication standard that is most common. So, there is no such standard which can be said as most common. So, sensor network, you could use most of the sensor network implementations use ZigBee, right. So, ZigBee based sensor network implementations are very I would say if I have to answer your question, I would say that I have noticed that ZigBee based implementations are very common, but it is not a question that can be answered in that particular manner, but ZigBee is something that you could try. Water body drainage monitoring of 10 by 10 square kilometer, what wireless ISM band technology can be used? 10 by 10 square kilometer, right. So, basically so there are so many things that you could do if you have a large area of deployment. Number one, you could go with your traditional conventional low range communication systems, plus there are like ZigBee etc., but you also have at present technologies such as LoRa for LoRa for long range communication, long range low power communication, right. So, LoRa can give you, like if you are implementing in an urban area, LoRa can give you 16 kilometers of range, wherever if you are doing it in a countryside with less noise of all kinds, you can get even up to let us say 50 kilometers of range. So, LoRa is one. There are other evolving ones like Sigfox, cellular technologies of different types. So, all of these can be. So, please go through my lectures on connectivity and you would be able to get more idea about the different other options that are there. Some other topics to supplement this course. So, one good thing that I would like to inform to all of you is that due to the success of this course since its inception, and because it was one of the first academic level courses not only in our country, but globally one of the first, you will find that there are a lot of earlier there were other courses that were also there, similar kind of MOOC courses, but this course, the beauty of this course is that we have made it more suitable for the academia. So, based on the success of all of these, the repeated success, the requests that are coming from all sectors, from the academia, from the industry, from our country and from abroad. From abroad also we get lot of, we have lot of audience and we get lot of requests. I have been traveling a lot to deliver lectures on IoT, and we have, I myself I have learnt a lot while offering these different sessions. So, based on our knowledge, based on our information that we have, the requests that we have received from different parts of the world, I am happy to announce to you that we have launched, we have released our book on Introduction to IoT, which is published by Cambridge University Press, UK. So, this particular book is in the press, and hopefully by another 2-3 months at most, this book will be in the market. And I have taken special care to ensure that there will be a cheap Indian edition in addition to the pricey US dollar and pound editions. There will be a cheap INR edition that will be released for the audience in India. So, I hope that will cater to many of the requests. Every time I get a lot of requests about study materials on IoT etc. So, I hope that this book will be a good comprehensive book covering a lot of different topics on IoT, and let us hope that it will be useful to cater to a lot of interest groups, lot of requests that are coming from the different parts of the world on this topic. So, you could learn, in case IoT is heavily network centric. So, in case you do not already have exposure to networks, like in case you have not done a basic course on networking, you could go through the basics of networking, TCP, IP, those will be helpful to you in order to So, the way I have I have designed this course is to help people coming from all kinds of backgrounds to be able to take this course, but I have abstracted many of the concepts at that particular level. But in case you want to know more and you have time and bandwidth and your prerequisite is there, I would encourage you to go through the basic courses on networking, where you learn the TCP IP in more detail. Additionally, learning Python is a big asset if you are working in the IoT domain. So, I would encourage you to learn Python as well. So, those will be like the supplements that you could do in order to enrich your existing knowledge that you are going to gain, that you already have, and the additional knowledge that you are going to gain from this particular course by going through these different lectures. How do wireless devices emit and receive signals. This is a difficult question that you have asked, in the sense that there is no one answer to this question. How do wireless devices emit and receive signals? So, basically there are channels that are there, right. So, there are electromagnetic waves. If you are talking about terrestrial systems, typically electromagnetic communication is used. So, EM waves are generated at selected frequencies. So, there is a sender which sends those electromagnetic waves. There is a receiver which will be always trying to catch these signals at those set frequencies, and then there is a complex stack, right. So, if you are talking about the regular wireless, not just IoT, there is a complex stack. Not so, what I just talked about, these signals and devices, emissions, receptions, etc., these are all like physical layer. So, then you have the concepts of the MAC layer or link layer, right. So, you have the concepts how the different devices can be sharing the channel, wireless devices, they can be sharing the channel. Then there are other concepts that are there. That is why I asked you to go through, if you do not already have those adequate prerequisites, not prerequisites for the course, but in case you do not have sufficient knowledge in networks, please go through those. That will help you to gain better insights about how the different devices in a networks over a wireless medium, they talk to each other. So, there are predefined frequencies will be there, as I said. So, basically what happens is there is a complex circuitry, right. So, people from electronics, right. So, electronics and communication, they design those circuits. So, they design those circuits and complex circuitry is there, and these signals are sent across. Additional thing that I would like to tell you is this is all about EM, electromagnetic waves, that I just told you for terrestrial communication, but I also told you earlier about one of the application domains is underwater. So, underwater means what? Acoustic signals will be required. Underwater, electromagnetic waves will have lot of a lot of impedance, right. So, lot of the signal will be attenuation will be there, high attenuation will be there. So, typically for underwater domains, acoustic signals, sound based signals will be sent, ultrasound or sound based signals will be sent. So, for that the circuitry is going to be different, for them the channel is different. So, everything changes, right. So, even if you want to build the similar kind of concept, but things change a lot, and there are lots of more kind of constants are there. In addition to traditional constants in IoT systems, you have furthermore constants in underwater environment, right. So, high error rate, very low bandwidth, very low, extremely low bandwidth, high error rate, then no provision for energy harvesting, like that. So, lot of different types of issues are additional issues are there, in addition to the regular IoT challenges that are available. So, can foreign wireless devices access information over wireless network anonymously? So, yes, but then you have the security features that will have to be implemented in order to prohibit that. So, the question somebody has asked is Internet of Everything, is IoE real? IoE is Internet of Everything. So, IoT, IoE, these are all these are all overlapping concepts, right. So, basically it is all about IoT, I would say. So, Internet of Everything, so basically there also you are talking about things only. So, Internet of Everything, basically it goes beyond, right, not just the things, but also you have people, process, data, everything connected together, right. So, it is vastly overlapping, but then there are few additional things you want to consider everything in place. It is all real, whether it is real or not, of course everything has to be connected, everything everything has to be connected, everything, right. So, in that sense, IoE is real. How are IoT software tested? Through long processes are there. And what is that IoT software? It depends. So, there is no one answer to your question, no one answer, long processes, whatever you want to do. There are so many startup companies working on IoT products. Sensor Drops Networks, as I said before, is a startup company where I am also associated in our institute, IIT Kharagpur. It is a startup company incubated in IIT Kharagpur. In case you are interested, go through Sensor Drops Networks, www.sensordropsnetworks.com altogether. So, please go through the company website. You would be able to get lot of information about the products that we have, the whatever we do. Like us, there are many other startup companies working on IoT based systems, IoT based platforms. So, not only us, but also the other companies, we work on real problems, real systems, but it is not simply interconnecting some commercially procured sensors, actuators, Arduinos and Raspberries. It is much more complex, a long process that is involved. Commercialization itself is a long process, and on top of that IoT complexity is even it's very complex, because IoT autonomy and intelligence are paramount, right. So, this is a very important thing. So, there are processes like you produce a beta version, alpha version, like that, So, like that, there are a lot of processes that are involved. So, basically, if you are talking purely about the software, so you have to follow the software engineering processes, right, over there, embedded software engineering processes. So, embedded software engineering, there are different models for implementation, and you go through them. So, we are very close to the we are nearing the end of this particular session. So, the last question that I will take is how to decide which protocol to use for which application. Which protocol to use for which application? Again, it is a open ended question. It depends on your application requirements. So, the specific communication protocol. So, earlier I said, for instance, if you want to do long range communication, there you have LoRa. If you want to do it for home based communication, ZigBee is there, not only home, outside also. So, it all depends. If you have an aqueous medium, probably you will have to go for some other acoustic signal, right, acoustic communication. So, which one, everything is given to you in the slides, in the lectures. The advantages and disadvantages are also said in most cases, and the choice will depend on your specific application requirements, right, and also the availability of the technologies. So, what I mean by this is that if you want to if you want to do everything yourself, if you want to develop the sensor material also, the sensing material, the sensor itself, right, and at the same time you want to network, you want to build the communication stack, you want to do the analytics, everything together, then that is not possible. It has to be done in different stages, different groups, by different people having expertise in these different domains. IoT is highly multidisciplinary, IoT requires multiple expertise, and IoT processes, IoT systems, development of IoT systems is highly complex, let me tell you, although it appears to be not so complex, but it is complex. So, here in this course we have tried to give you a broad spectrum knowledge of the different things. We have tried to introduce to you many things together, while consciously keeping in mind that this course has wider audience and catering to the existing prerequisites they may likely have. We have designed this particular course. We have tried our best to give you enough knowledge, so that based on your specific requirements that you have for a particular problem, you would be able to dig further deep into and gain more insights and research more and develop your systems. But remember, as I said before, IoT is real, IoE is real, there is no hypothetical thing that is going on. These are futuristic technologies in the sense that these are going to make your system smarter and smarter in the future, but these are all going on. There is nothing that is hypothetical in nature. So, with this I would conclude this particular session. I hope that I could provide you more insight beyond the the lectures that are there. I would urge you once again that you please go through the materials that are there and try to go through them. and in case you have more questions you could ask in the discussion forum, or you can wait until the next discussion live discussion session like this. With this, I would wish you all the best, and I hope that you enjoy the rest of the lectures of this course. Thank you.